All right, so this is the review for question number 2. This is also an example of your chapter 3 question. So remember, our chapter 3 questions are all about that molecular attraction. And when we think about our molecular attraction, if we have a strong attraction, we can also think about this as a strong magnet, right? If I have a strong attraction, that means two things. Strong attraction means it is easier for the molecules to come together and harder for the molecules to move apart. Just like that, it is opposite for that weak attraction, or we can think about that weak magnet. For a weak attraction, it is easier for the molecules to move apart and harder for the molecules to move together. So thinking about the difficulties of moving my objects closer together and further apart and what that means for us, we are going to now look at our question and let's find the important information that we need to know for this. So a scientist has two substances that she is testing in her lab, a pink substance and a green substance. At room temperature, both substances are liquid. So we're starting out in a liquid. The scientist is going to transfer the same amount of energy into both substances. So my energy is going into. Only the pink substance changed phase. How is the pink substance different from the green substance? So looking at our pink substance versus our green substance, we need to determine which one has the weak and which one has the strong attraction. That is what we're trying to figure out in this question, okay? Which one has the weak and which one has the strong? So thinking about that, what do we know about this information? We know that a liquid, it's starting out as a liquid, and we know a liquid's molecules are moving around, okay? We know that the liquid means the molecules are moving around. The other thing we know is that into, I always equal to increase, because if you look at into and increase, I have an IN into, and I have an IN increase. So if I have IN, into means increase, right? So if I am increasing, I'm increasing the molecule's speed and temperature, and the molecules will move away or further apart. Okay, so as I transfer energy into, I'm increasing the molecule's speed and temperature, and those molecules will eventually start to move away or get more space. They're going to move apart from each other. Okay, so thinking about that, we know that it started as a liquid and we're increasing energy. So what should it become? It should become a gas, right? If I increase my energy of my liquid, it's eventually going to become a gas. And we can look at that, right? If I start with a liquid and I slowly transfer energy into my liquid, it should become a gas, right? Super easy, nice to become a gas. So this is what should happen. If we notice, as I transferred energy in, it becomes a gas because I have a weaker attraction. So this represents my weak attraction. Okay. And it was easy to move the molecules apart. Easy for the molecules to move apart. It was easy for the molecules to move apart. Now let's look at another instance. So I'm going to still have a liquid, But now I'm going to have a strong attraction. So the first thing I need to do is I'm going to make this a liquid. All right, so I have a liquid, my molecules are moving around each other. And now I want this to become a gas. If I have a high attraction and I want this to become a gas, look at this already. With a strong or high attraction, I'm already so high in temperature. If I want to become this a gas and I'm going to transfer more energy in and more energy in, do you see how I'm at the highest temperature and I still don't fully have a gas? This represents that strong attraction. And it is hard to move apart. So let's look at those two and compare again. This is my strong attraction. I have the highest amount of temperature. I'm not even at a liquid yet. You can see that the molecules want to still stay together. This is my weak attraction. I'm not even at the highest temperature and I have a gas, and the molecules easily moved apart. So comparing this sim to this sim, I'm going to be thinking that a weak attraction is easy to move apart. And we know that I want my molecules to move away or move apart because I'm transferring energy into. So if I'm transferring energy into a liquid, it should become a gas. So the first thing I'm going to look for in when I have an option of all of these is let's find the one that talks about a gas. We know that a gas does what? Gas moves away, right? Gas moves away. So thinking about how gas moves away, coming down here, let's find the ones that say move away. The molecules now move in place. That's a solid. The molecules now move away. Oh, gas. So it could be that one. The molecules now move away. Gas. It could be that one. Molecules move around. That's a liquid. So right away, I can already get rid of this answer and I can get rid of this answer. So now I have molecules move away, which are both gas. And so now we want to determine stronger attraction or weaker attraction. Well, we already know if I have a weak attraction, it's easier for the molecules to move apart. And we saw that in the sim. So if I want the molecules to move apart, move away from each other, then I'm definitely going to want to have that weaker attraction.